In the room to learn about Azure, put up your hand. Everyone raise your hand unless you're in the wrong room. Anyone here server hugger? Put up your hand. I didn't know if that term translated correctly in Australian or not. Back in North America, I'm not American, I'm Canadian. Back in North America, a server hugger or a tree hugger is someone that saves the trees. So a server hugger is someone that saves the servers. That's where that expression comes from. This is a ServerHuggers perspective of what's new and cool in Microsoft Azure IaaS in particular. My name's Rick Claus. I'm a senior technical evangelist or senior program manager, and I work in a company or a group called DX, Developer Experience. Don't know why they put an infrastructure guy inside of a developer experience group, but that's a conversation for one of the taverns down the road at some other point in time. I'm going to be sharing some of my insights from a ServerHuggers perspective with regards to what's new and cool inside of Azure IaaS. I work with the Azure Compute team in Microsoft. Mainly, the team is responsible for infrastructure as a service and all things compute with regards to Azure. And I always bring the perspective of an infrastructure person to this discussion. So I'm not going to be opening any Visual Studio. I'm not going to be showing you any code. I'm going to be sharing a bunch of stuff that I find interesting. The problem is that this talk changes all the time. The reason why is because Azure changes and ships stuff on a weekly basis, if not daily basis in some cases, from multiple dozens upon dozens of different teams to make it into the service that we know and use at this point in time. So if you've never seen me before, I've been to TechEd Australia and Microsoft Ignite in Chicago and TechEd Australia in previous incarnations over the years. I always wear the same hat. In case you haven't seen me before, this is a Tilly T3 hat from Tilly and Durables. If you want to find out about me more, you can reach me on about.me/RickClaus, on the Twitter sphere at @RicksterCDN. You can also find me at regularitguy.com. But if you're looking for me around the social activities here at the conference, just look for the guy in the green hat. Literally, it doesn't come off my head. Azure, 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 Azure. Literally, I was having a conversation with my boss about 2 years ago. Who says, Rick, I need to have someone that is on the team that can take a look at and handle the stuff that's responsible for the Azure space from an infrastructure and IT pros perspective. And I'm like, okay, I'm the guy that comes with like 20-odd years of experience of schlepping servers and racking them and server accessing them and making sure that they're all happy and everything's all working. I'm an infrastructure guy. He's like, no, we need to have someone that's doing this from an infrastructure perspective because the group that's inside this room right now are people that work with server infrastructure, used to on-premises infrastructure, and now they're moving to looking at what is this thing that's upstairs inside the cloud environments on our premises inside the Microsoft world. This slide is already out of date. It was out of date probably a week ago, easily, with regards to the sheer size, scale, and momentum and growth of the stuff that's inside of Azure. It is absolutely massive, the stuff that's been going on in there. And it still freaks me out that I have the ability to create an account on Azure, give it some kind of billing capability that I can have charges against that particular account, and then I can spin up whatever I want and whatever I can pay for inside of an environment. It's awesome, absolutely awesome. And the best part is I'm using the same tools and things that I'd normally be using for my data center down the street or down the hallway or under my desk. It's all the same kind of stuff. So I think one of my, well, I guess I could say friend. Brad is everybody's friend. Brad Anderson was telling us at the keynote on Tuesday that we're investing over $5 billion in our data centers every single year upon year. That's on top of the money that we already spend on all the R&D and development that we spend as well. So with that note, if you're working for an organization or if you're thinking about procuring services from an organization that isn't spending billions of dollars to keep their data centers up to date and their infrastructure up to date, they may already be out of date and no longer a player inside of the public cloud space. It is rapidly, rapidly evolving. So talking with infrastructure folks, like the ones in this room, I typically get asked questions about, well, you know, I'm used to doing stuff on premises, this cloud thing, kind of interesting, kind of want to see where it is, but I'm really not comfortable going there just yet. I kind of break it down in a couple of basic areas I want to cover through and talk about those nuances and differences inside those different areas about the Azure space and about the Azure world. And those typically tend to be, hey man, let's talk about hybrid connectivity and what does that mean. Let's talk about scale and what does that mean. Let's talk about security and what does that mean, because those are typically the three areas that I get asked a lot of questions about when it comes to infrastructure. The first one's about scale and size and massive size. Global coverage, you all know, tech ed. Was tech ed last year. Phew. You have to put $5 in the jar whenever you say tech ed instead of ignite as a speaker here. The jar is very full, I will say. Very, very full. Sheer scale and size, we did the announcement about the fact that the Azure data centers are open and available for business here inside of Australia as part of a partnership organization that we have working with stuff. But to kind of put that in perspective, think about the growth over the last while. Microsoft has had data centers all around the globe for a very, very long time, running various different services. And now we've basically gone through this massive project over all the years of bringing these services and consolidating them together to make them more efficient. When it comes to any kind of a cloud provider, you have to provide services efficiently. And so in 2013, we had all these data centers around the world. We had Europe, we had North America. We didn't know that there was people that wanted to use it down in Australia or South America or Africa or Canada. Canada's missing out of there too. But then 2014, all of a sudden we opened up Australia, we opened up mainland China. We also opened up more areas inside North America, and Brazil came out as well. And then actually just this year, we also announced that we have them in operation and already to go inside of India. Canada was announced as well. And just last week, we announced the ability that we're going to be opening up in England and also in Germany as well. Crazy, crazy growth and changes coming on. Now, when we talk about scale and size, again, the biggest server rooms you've ever worked in before, the analogy is, this is the North American analogy. Those are lines supposed to represent an American football field, but think of it like a rugby pitch. How's that? You can land a couple of jumbo jets and park them on that rugby pitch. And if you put them all together, that's the approximate size of one of our, kind of typical sized data centers that we happen to have in one of the regions inside the United States. It kind of puts into one kind of perspective, 600,000 odd servers inside racks and racks of servers inside some of those regions. But I tried to find something better, and so I think you guys saw this photo the other day. I want to kind of explain a little bit. This is an undisclosed data center that we have in the eastern seaboard of the United States. This guy in the bottom corner is actually a semi-truck. That's for scale. That's a semi-truck that's there. And that's one of the existing data centers, and you can see the cooling towers. You can see how the different things are organized in there. But in the back, you see the expansion. Here's the expansion. This is 5 square kilometers of server racks going into play. Just wrap your head around that. That's one of the expansions that we're doing in one of our regions that we have that's out there. We're serious. We're not going home. We're making some substantial investment into this environment. So absolutely awesome. We basically put capacity where we need to have capacity, where anyone wants to go off and consume it. And Australia is one of those examples where we're even able to do stuff very quickly with partners and with other organizations and even our own data centers that'll eventually be able to grow and become as big as required for the customer base in different areas. So that's just one concept as far as hyperscale goes. You know how many people work in this environment? If I go back to right here, how many people work in that data center? Do you know? 12. 12 people inside that data center. You know what they do? 90% of their jobs, HVAC. HVAC and electrical. All the operations for all that, how that thing works does not take place at that location. It takes place elsewhere in a NOC to be able to access that. So again, just sheer skies, 5 square kilometers, absolutely insane. We got scale down. Now, this is one of the big things that I always like talking about, and this is something that my good friend Mr. Fox covered probably in this room earlier, talking about all things to do with networking. One of those things was hybrid connectivity, where you, from the simplest terms, from how all of us can relate to hybrid connectivity, is how do I connect up to that subnet that's up there to be able to make it so we can talk to my subnets on my on-premises environment. So hybrid's a really good differentiator from a story perspective of how we work. And what that really means is, okay, look, I got resources on-prem. I've got them where they had databases there. I've got resources there. I want to go off and dynamically expand and have a subnet up inside of the Azure data center, whatever it happens to be, and I want to be able to access it without having to worry about any kind of connectivity issues whatsoever. The simplest form of connectivity, mostly for development environments, is called a point-to-site VPN over a 443. One machine can talk to that subnet, unobstructed, it's all good. Fantastic, very simple, not very scalable, good for test dev. Next up is the VPN capabilities. You can use a piece of hardware, a Juniper device, a Cisco device, or a software-based router if you wanted to. That's as site-to-site VPN connectivity. We even give you the scripts to be able to configure this. If you haven't done this yet, take the time to figure out how to get a site-to-site VPN working from your lab environment, from your home environment. Learn those skills to be able to go ahead and to do a site-to-site VPN connection so you can understand how to route packets back and forth between two IPv4 subnets inside of this world. Very simple. You can do that even with a trial account from Azure.com to be able to do it. The granddaddy of them all is called the Express Route, including the partners we have here in Australia, which will give you access to, oh, that was weird. Okay, it's back again. Dedicated connectivity. Picture this as literally a connection to your service provider that's providing you your wide area network connectivity. You then make a new MPLS circuit from there to from your center through their data center over to our data center at one of those different regions for an express route. The difference with this guy is that all the traffic goes through that connection, does not go through the public internet as far as connectivity and privacy is concerned. And it's also redundant. There are 2 copies of that circuits going through there. So in theory, you get lots and lots of bandwidth, which is quite cool. Also obviously used for Office 365 as well if you wanted to. Very simple connectivity, more detail. Go see Stu Fox's session. It's going to be up on channel9.msdn.com in the not too distant future because he goes into some nice gory depth and detail about this and hopefully some good humor too. Now the last one I talk about really quickly is about security because I can't touch my servers anymore. I can't go and stroke them and work with them anymore. They are no longer there. And that's a big jump that we have to do from a trust perspective, and that's something that we all have to come to terms with. But we put everything in place to try to build that trust for you, and we're going to do everything to keep that trust as much as possible so that it does not get broken. And so I think of this as a multi-layered onion approach with the concept of physical control. That picture of the data center, if you didn't look closely, it actually had a chain link high fence with barbed wire around the entire perimeter. If you looked very closely, you actually would see that there was also a security path around that entire data center that the security patrols would go around. And those are security patrols that are actually armed security patrols. More than I have in my data center server, that's for sure. But then also, we've obviously got barriers, fencing, two-factor access control, biometrics, all sort of stuff. I can't go see a data center without a reason. And even if I can, I couldn't get into a certain area in that data center. I can't get on the floor because I don't have clearance to do it. Infrastructure-wise, once you're inside that data center, our infrastructure has been designed from the ground up to be available to anyone that wants to use it as a customer, but it's been designed as a massively multi-tenant environment with all the security safeguards put in place, all sorts of resources internally to make sure that nothing leaks between them, and we put that all in place with our fabric for how things work. We have whole teams dedicated to compliance, yada, 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 sales, sales, sales. That's all I'm going to talk about as far as compliance, certifications, infrastructure is concerned. I'm kind of geeking out here about the networking side of things with the way that we do stuff. Some of the latest stuff that we talk about, I'll talk about a little bit later on, which is what you can do with your subnets, how you can control traffic between those subnets, between machines on those subnets. You can do all that sort of stuff from a networking perspective. And then obviously very last but not least is the physical VMs themselves. All those VMs run on top of our infrastructure. They all have the ability to have anti-malware on there. We have security extensions built into those boxes. We have the ability to do logging and auditing with inside of your accounts to find out who's been messing with your accounts inside of your own subscription. All sorts of stuff is good. Multi-layered. My mother used to tell me, and I believe this is absolutely true, it takes an eternity to build trust. You have to prove it with your actions. It takes one action to break that trust, and you're not going to get it back again. So you can bet that any cloud provider worth their salt is going to be doing everything in their utmost possible power to ensure that they will get your trust so that you can go off and be comfortable using their resources. Because you can't go down the hall and take personal responsibility to say, this is my stuff. Now you have to say, this is my stuff over here inside the Sydney data center, inside the Melbourne. It's Melbourne, isn't it? The other one is? The Melbourne data center. That's where it happens to reside, or even if it's elsewhere inside the world. So every single team that is responsible for ensuring the integrity of that data center is doing their best to make sure that's absolutely integral and strong. But you're here to learn about IaaS and the new stuff with IaaS, IaaS infrastructure as a service stuff. So that's kind of all the background to build the trust and understand where things are coming from. I like to talk, first of all, about compute. I'm a geek. I love hardware. I work with hardware. I spec out servers and that sort of stuff, and I enjoy doing that kind of stuff. And so I like to kind of think of infrastructure as a service and about Azure in a form where I can relate to it, which is obviously talking about CPUs, cores, performance, that sort of stuff. I've got a session tomorrow talking about how to architect highly performant systems on Azure from an infrastructure perspective, not from a developer perspective. That's coming up tomorrow. So I have to talk about compute. And so if you saw those data centers, picture racks upon racks upon racks of servers designed in such a way that we have things that are called compute stamps, we have things that are called storage stamps, and the compute stamps talk to the storage stamps, and the fabric connect them together. We've got the network connecting them together. It's all good, but as far as you're concerned, all you see is a web interface that says file new compute, here's my location, answer 5 or 6 questions and go. And so these stamps or these CPUs and this rack of servers that are in there, they have a bunch of different resources that are assigned into what we call families. Very simply, from a progress for how things have grown over the years, A is the original value for the A series family that we happen to have. AMD, Intel, very cost effective, very cheap to go off and run. D is the one that we brought out a little while ago, which is basically new Intel-based processors. The cool thing about the Ds is that they actually have local SSDs on the blades that run the hypervisors that are on that box, which means we have much more faster performance. We also have the Gs. They were so awesome, we skipped over top of the E's and the F's, went right to G. It also has an analogy to a particular reptilian monster from sci-fi times that I can't say because of copyright reasons for why they were called Gs. Then also we introduced premium storage. As far as I remember, looking at the Azure services that are available inside the local data center here inside of Sydney and in Melbourne, you don't have the Gs right now, but you do have Ds and you do have premium storage. So that's actually most likely the ones you're going to end up using. The Gs are a very, very special case where you want to use them. We announced a couple of weeks ago, well, we're still the largest virtual machine available that you can rent inside the public cloud. But we announced a couple of weeks ago something called the DV2s. DV2s is the wonderful marketing technology that they created that simply put a V2 at the end of the D. And what that means is simply newer hardware. Latest generation Intel hardware is coming out there. They're 35% faster than the old Ds. The old Ds were 50% faster than the old As, so we just keep on getting better and faster. They're basically available in select regions, and they're going to be rolling out as demand requires anywhere it's out there. We also announced this other really cool new one called the N series, based on the manufacturer of a particular GPU that goes inside that one there by NVIDIA, which is set up for remote virtualization, set up for very compute-intensive resources. I'm interested in them because I do video editing sometimes, and they're absolutely awesome for encoding because they support CUDA as far as encoding is concerned. So cool stuff there for compute-intensive stuff. Now this is pretty intangible to a lot of people at this point, so I thought I'd kind of quickly just jump out here, see if my machine, of course, it locked up with a password before I unlock it and show you. And of course, because it went to sleep, it's got to now do the password. Ah, there you go. I have to assume that most people have already gone ahead and gone into, oh, lovely, gone in and used Azure Portal before. This is actually a demo that's on purpose because I wanted to show you this one little thing. This is a policy that we happen to have inside of Microsoft that you could enact in well inside of your accounts that allows you to have multiple form factor authentication into your resources inside of Azure before you can even go off and do stuff. I don't have a smart card on my demo machine, so I'm going to have to go in here and put in my password. If I can do that with everyone watching. That's working great. But notice what it's doing here. It's actually calling my phone here in Australia once the bits connect and come through. Come on. There we go.
Thank you for using Microsoft Sign-In Verification System. Please enter your PIN followed by the pound key to finish your verification. If you do not initiate this verification, someone may be trying to access your account. Please press 0
I did it.
Fraud alert.
Come on.
This will notify your company's IT team and block further verification attempts. Verification denied.
Oh, lovely. It works great. It detected the fact that I was actually in Australia. I should have been in Redmond. No, I'm lying. It didn't work. I made a mistake on my password. Let's go through and try this again. Do this one. portalazure.com. This one's going to go through, and it's going to be happy because it's cached. Boom, I'm in. Good. That's what's supposed to happen. And it would have actually gone ahead and done that for me anyway, and we're all there. But again, just to kind of show you very quickly, new compute, you guys have seen this before, but I want to show you this one thing option from a compute resource. I want to go through and bring up let's bring up an Ubuntu box. Change this to Resource Manager, answer a couple of quick questions as it catches up. Call it Linux AU, my administrative name I want to use. I'm going to keep this simple because it's a demo with a password as opposed to a certificate. I'm going to choose an existing resource group, deploy it to Australia, and when that catches up, from a sizing perspective, this is actually going to show me what's available inside of Azure Data Center here inside of East Australia. So I've got my DS's, I've got my D's, and then beyond here, I've got my A's as well. And the neat thing is you can actually go through and you can take a look and see from a cost perspective, if you left this running 24/7, how much it would cost. $1,249 US a month, if you left it 24/7. But the good part is you don't have to leave them running 24/7. But then you have all these grayed out ones, the DV1s, the DV2s, the Gs and the G5s. Here's the G5, look at this, this is awesome. $6,465, $64.65 a month if you left that running 24 hours a day. Absolutely massive in size. I'm going to keep this simple because mainly I got in trouble last time I tried to demonstrate a G5 and left it running for the weekend. I don't recommend that. It's not too bad. It's only about $400. Take the defaults. Thank you very much. Go through and deploy. Thank you very much. And go. Goes ahead and deploy. Off it goes. Everything's all good. As that deploys, it's off and running. From a G series perspective, to kind of put that in perspective, they're not available inside of Australia at this point in time. As demand comes up, they might be available in Australia and other locations as well. As customer demand comes up. But let's put this in the context. If you've bought servers before, I used to spec out servers. To spec out a server that is a 32-core system with 448 gigs of RAM, 7 terabytes of local SSD space, last time I checked, it's rather expensive. And in fact, the last time I checked, here's a bill, $66,000 to spec out this box from a good friend like Dell, as an example, non-manufactured discounted prices. Now, we all know when you buy that, it actually costs you 3 times that amount over the depreciation of the life of that server for the actual cost. So we're talking $180,000 US dollars spent to be able to buy this box, to have it run 24/7 inside my data center, consuming energy and consuming resources. And the best part about this is, it's not going to get here for 15 days. I could have, by the time I used to explain this, already have deployed a G5 and had it up and running inside of my subscription for the exact same specs. That's one of the advantages of going to a cloud environment. And the best part is, like I said earlier, you don't need to leave it running the entire time. You can always go and take it down, and you don't pay for it on a per-minute basis, and it goes away. So people like to say that moving to a cloud environment is going to save you money. It's not going to save you money if you leave them 24/7. It is, it's not, it's a constant debate. It comes down to one of those questions like it depends, or statements of it depends. You have to choose an agile way of spinning stuff up and shutting things down as you no longer need to have them anymore to be able to go off and to take effective use of the cloud environment. That's my quick little parody and talk about what's going on the Azure infrastructure side of things, just from a pure compute perspective. So storage is the next piece that you have to understand. And from a storage perspective, really it comes down to, when I spin up a machine like I just did, and I said, here's my operating system, Ubuntu, I want to go off and spin it up on a D2 machine inside of the Azure data center inside of Sydney, it's actually going in and taking a copy of that particular VHD file, copying it across the network internally at Microsoft's data center, and then mapping it down to a particular blade running the hypervisor fabric that the box is on, and then allocating me the proper amount of CPU cores and RAM for that particular box, and doing some other magical fun stuff too. But the C drive is a local disk on that box where the VHD is stored. You have a disk cache routine, and then you have a D drive, which is the local disk as well, being used for cache, but that disappears whenever that machine is moved or restarted anywhere or deprovisioned anywhere. So you have to be aware of that. As it goes through and does writes, it's able to go off and access the disk cache, or possibly have to go back and talk to that blob in the back end. I like to equate this in very simple terms. A series families, their D drive is spinning Rust. It's an actual spinning disk. D series and G series are SSD based, so you get much better performance. So the blades are more up to date. They have SSDs. When you attach a disk, what you're doing is, again, you're bringing a blob from someplace else, you're bringing it down to that box, and it's making it so that it's able to go in and function and work as it should for D drive, E drive, F drive, and G drive, and sort of stuff. And then you're able to go off and to put data that's on there that's resilient and will stay with that box as it moves around or as it needs to move around. Now, this brings up an interesting conundrum, which I'll talk about tomorrow. When I go and write my data to that data center on that local disk of that box, it's actually going to go ahead and write 3 copies of that transparent to me because of the fabric to protect it. So if that particular storage infrastructure it's copied to is no longer available for some reason, I have another copy of that data available and transparent to me. I have access to it. So we do the resiliency for you inside of our data center. That also could be possibly taken to the next level and actually replicated between Sydney and Melbourne if you wanted to make it so that data becomes available in 2 different locations. The last part is talking about networking and networking connectivity. And the big thing that came out, which is new as of last May, is something called security groups inside of our environments. A subnet is a subnet inside of Azure called a VNet. You're able to carve it up into different subnets. You can assign rules to those different subnets with ACLs for who can talk to what. You can also go through and define a security group that says these boxes can only talk to the middle tier and are only going to be across port 80 internally. The external boxes for the front end are only going to be able to receive content from the outside world or from the middle tier. They're not going to be able to talk to the back end tier directly. You can define all of that inside of your infrastructure as you see fit inside of Azure. So this whole concept becomes very important when you're defining what your project looks like for when you're going off and deploying something inside of an Azure environment. This is where I normally will take a pause for a question. And I'm using a placeholder for my questions in case anyone has anything about so far. And so I decided to use some of the stock imagery because as a speaker we had to go through and clean up all the images that we had to make sure that they're all good. So this is a stock hipster image that Microsoft Marketing likes to use as this is an IT person working. So any questions so far for understanding the basic concepts of compute, storage, networking in the Azure world, provisioning workstations, provisioning services up inside the Azure environment? Any questions? Very quiet. That's good, I think. So what's the latest and greatest and newest stuff that you have to be aware of? Well, probably, I had this discussion with some of the speakers earlier, probably it's the same level of transition that you might have made. Who here is a PowerShell aficionado? That's been working with PowerShell and works with PowerShell. Hold your hands up nice and high, be proud. Okay, I'd say it's probably about a third of the audience, maybe a bit more, that work and use PowerShell right now. How long ago did you start using PowerShell? Just anybody, shout something out. How long ago? 2 years? Someone in the very front there said 2 years. There you go. You get to have the very first prize, ma'am, of a Canadian maple syrup. That's yours. Come down and get it later. You don't have to get it now. That's yours. Don't forget. Yes, there is interaction in this. It helps. The reason why I asked 2 years, it came out about 5 years ago, and not too many people were into it. They're into using GUI environments, and they didn't see the value of what's going on. Some people jumped on very early. 3 years ago, 4 years ago, more people got on the bandwagon, more people using it. I use it. Everyone uses it now. But it's taken some time for it to catch on, and it's a mind shift for how to go off and change things. After PowerShell, that's the latest thing right now with WM5. Latest thing with PowerShell is everyone's big talking about right now. Is you have to know this, otherwise you're going to end up behind everybody else. I'll give you a trick. It starts with 3 letters. DSC, desired state configuration. DSC basically is the next generation of being able to make a declarative result, or it's a declarative file that is able to go off and say, hey, this configuration needs to be applied to this box. It detects drift, it fixes stuff, it applies it. You don't have to write this massive amount of logic. It makes a lot more sense. DSC is where it's at. The next iteration of things you need to be worrying about after DSC is now working inside of a hybrid environment, working with Azure and working with the now future discussion around Azure Stack, which could be deployed inside of your own environment. And that is this: Azure Resource Manager and ARM templates. If you come to any of my talks, I've got another one this afternoon, another one tomorrow. I'll be talking about ARM templates in varying degrees of depth for why they're important and why you need to pay attention to them. But basically, this is a declarative file that's being used that then gets hit by the Resource Manager services up inside of Azure, interprets it, and knows what APIs it has to hit to go off and to provision your storage, provision your networking, provision your VMs, be able to configure your subnets, configure your ACLs. It's all done through this one file, which is formatted inside of a text file known as a JSON file, and allows you to do a whole bunch of stuff against this particular infrastructure you've now gone off and deployed. It literally is the embodiment of what we're calling inside the DevOps world, infrastructure as code. You define your subnets, your storage, your VMs, the images, the sort of stuff that are on them, and it's stored inside this one file. And then whenever you deploy this file, it's always going to be the same. It does not replace PowerShell. It complements it in the Windows world, because at the end of defining all that infrastructure and defining the 15 different VMs that are inside of it, it sticks in and has this extension called the PowerShell extension, which can be used to fire off a DSC environment to make it so that those particular VMs are now configured properly for SharePoint or configured properly for a highly available SQL implementation or whatever it happens to be. So DSC complements this. ARM templates are something that you have to get your head around to understand what they're for. They all sit inside this Resource Manager environment, and the Resource Manager environment is used inside of your subscription to group things together, to group your resources. You can deploy security to those resources. You can deploy security and roles to those different resource groups. And the best part about them is, especially for me, is that when I'm done my demos here in Australia, I just go in and say, delete resource group, and all the stuff inside of them is gone. Because its infrastructure is code, it disappears, and I can recreate it again as required. Last thing, which is very important for the infrastructure folks, is the fact that you're also able to go in and associate tags with all these different resources. Tags can be used for assigning identifiers that you choose what they are, which group your projects logically within your own internal billing cycles, as an example. So you know that the different dev test teams or whatever they happen to be are going to have their infrastructure tagged with a certain information. That shows up on the bill for what it is. So Azure Resource Manager groups and tags become extremely important. So from a resource manager perspective and how this all flows through, regardless of the tool that you're using, the portal, individual command line through PowerShell, or if you're using Visual Studio, you're going to be going through the Service Management API down to Resource Manager, who's going to be interpreting what's going inside of your ARM templates, going ahead and, on your behalf, contacting the different resource providers to go off and to hit your networks, your VMs, your Azure App Services, your resources, your storage, and then makes it available for you to be able to use. So how does this appear inside of the Azure environment? Pretty simple. When I go through and say, for instance, new resource groups or new compute, I'm going to go ahead and, how do we go through and do a marketplace, see all the different resources that are there, and do SharePoint as an example, 2013 HA Farm. Choose that one there. Notice that down below here, it tells you deployment model is only available as a resource manager. It's because we build the logic for you for a multi-tier environment that includes 2 different domain controllers, 3 different highly available SQL servers, and 4 different web services that run SharePoint front and back end for you. I go ahead and hit create. And it goes through and interprets that template, which was made by somebody on the Microsoft team, and then allows me to fill in these parameters. I'm not going to go through this because it actually takes me about 5 minutes to fill in all 6 pages of all the stuff it's asking me for, because it's going to ask me for SharePoint administrator names, domain names you want to use, storage accounts, stuff like that. But basically, it can be as complex as you want it to be able to go off and deploy a fully available HA SharePoint implementation. When I was a consultant before joining Microsoft, this is my bread and butter. designing complex architectures for different solutions. Now it's a template that could be used with enough intelligence of how to go off and create them. So templates come in all shapes and sizes. They come in and are quite helpful. They can also go through and do very interesting things. To be able to go off and to choose an example for Minecraft server. This one is a very simple one going through and doing a classic deployment model. But it could go through and run an extension at the end, which is a bash shell script, which will go in and download the Minecraft executable, do the install, configure it with the appropriate text files in proper locations to go off and have a pre-configured working Minecraft server as an example of one possible thing that works off of a Linux box. These templates are all available for anyone to use in what's known as the Quick Start Templates environment. If I can click on the right option here, there we go. And you can see here the Quick Start Templates come up in versions 100 for 101s. They also go 201s and 301s from a level of complexity for what they happen to be. These are all your jumping off learning points for where you can learn about how templates work. Templates are not something you just dive into and just start to make a template from blank because it's ugly, very ugly. It's a reason why it's called JSON or Jason from the Friday the 13th series because it's really just quite scary to be able to go off and use. That fell on deaf ears there. Wow, good stuff. The documentation team has gone very good and gone ahead and done a whole bunch of different sample templates you can go off and use to be able to go off and to learn how to deploy, how to work with stuff. I'm going to pitch a session for you on Friday by James Bannon, who's going to be doing a very in-depth discussion around JSON files, how to edit them, how to work with them, how to configure them. I strongly urge you to put that into your schedules. And if you can't make it because of a conflict, go watch it after the fact because he's going to have some great stuff in there about how to go through and author them and work with them from a learning perspective from an IT pro. So very, very important as far as where JSON files are concerned, how templates work, that sort of stuff. Go back to there because I need that. Go back to here. So resource manager templates, basically, they simplify deployment. They allow you to do rollbacks. They allow you to go redeploys. This is the step towards going and learning how to do your infrastructure as a infrastructure as code implementation. It literally is simply a text file that you have to go off and edit. It has a certain format and flow it has to follow. You can put dependencies onto them. You can have multiple tiers of machines, multiple configurations. Believe it or not, it is way easier than going through, after you understand how they work, than going through the portal to go through with human error and recreate stuff all the same way. The best part about this is, more so for the coding people that are inside the room, they're basically source files that can be checked into your source code repository. I have a session this afternoon talking about that from an infrastructure perspective, how you can go off and talk about source files and how they work. The basics of how a JSON file looks like really comes down to have, as you can see here, 6 different areas that you have to be aware of. Schema simply tells you the fact that you're using a particular schema to define all the different resources inside of Azure. That one is basically static. You then have different parameters. The parameters are the pop-up options that they give you on the website, as an example, to be able to fill in the different variable names for user IDs, passwords, Minecraft server names, SQL server names, SQL server instances, and stuff like that. They can all be found inside the parameters area. You define what they are, what type of strings they are, what type of stuff can be pre-populated. If you are making these, can I give you a word of advice? Please put something meaningful in the description of each of the fields. It doesn't help me if it just says server name. Which one? Is it the domain controller? Is it the SQL server? Is it the SharePoint server? What naming format should it have? You can put all the logic in there, but if you just put in username or server name, it doesn't really mean too much to me. So make sure you go in and use good descriptions in there. You have a static area of variables that you can populate. And you can actually populate almost everything inside of this variables area and then call those variables inside of the rest of the JSON file to be able to go off and do stuff. So here you can see things you probably are pretty familiar with seeing here. I see public IP address. I see a VM name. I see a size that I want to use, what the name of my virtual network is going to look like. This is you defining different pieces of code inside of your infrastructure that you want to go off and to use. So it's otherwise known as parameters. Then you have individual resources that are being called. You can see here that I'm creating a new storage account. I'm going to go ahead and make a network and make a request for a public IP address. All that sort of stuff is contained in there. Like any other type of code, even with PowerShell, if you're doing a big massive script, if you put in a semicolon versus a full colon, if you put in a comma instead of a full stop, it makes a very big difference and can blow up your file. There's some interesting stats with regards to people, and this is kind of interesting. Who do you think makes more mistakes inside JSON files? Developers using Visual Studio or IT professionals using PowerShell? Who would you say? He says IT professionals using PowerShell. Developers over there in Visual Studio? It's the developers in Visual Studio, believe it or not. They make more mistakes in it for where it comes out. So actually, they make about 2.5 times more mistakes than the IT pros do with the PowerShell commands for the way to do this. So yes, you can actually use 3 lines of PowerShell to deploy a template that will go off and build out that massive farm of information if you wanted to, all just by simply using 3 lines of PowerShell to be able to go off and to do it. Then also you have some ability to go through with those resources and define default values if you wanted to. And then the outputs also have ability to go through and put on dependencies. So this is kind of a thing that you have to be aware of, again, since last May. If you were already using Azure, or if you've been dabbling in Azure before, and you see something referred to as Classic, Classic is the old way of doing things, known as Service Manager way of doing things. That particular way made it so that you basically had to do one process. It wasn't able to be parallelized, and you couldn't do any interesting logic. The new way of doing things on the Resource Manager uses ARM templates and uses the new API set, which basically makes it a lot better and faster. So that means you can do massive parallel deployments of machines. You can go through and have more fault domains to be able to worry about as far as how fault domains work inside of your environment. You also have the ability to do custom URLs and custom scripts extensions and everything else. So let me just give you a quick show of how one of these templates works and how that works inside of Azure from a perspective. I have my resource loop set up for VMs in this particular case. If I go in and make this a little bit larger so you guys can see. This is going to go through and basically deploy n number of VMs. The default number for n is about 20, I do believe, for where it goes for this particular thing. So this documentation is quite good for being able to deploy and to talk about the basics of what this does. I'm just going to go ahead and say deploy to Azure. It's going to make sure I'm signed in. Cross my fingers, I don't have to do the dial. I don't. Brings me back to my template. I'm already authenticated to my environment. It then goes ahead and makes my new compute and takes the information from that template file and then pre-populates it and asks me for my parameters. So in here, I'm calling for my admin username on all these 20 machines. My password I want to use. The storage account name I want to have them all stored inside of. Here's one interesting thing. Example of bad documentation, unique storage account name. We don't bother telling you that you can't actually put in uppercase and lowercase letters for your storage accounts. They have to be all lowercase. Can't have punctuation. It's just, in this case, letters and numbers. I'm doing 20 instances to keep it simple. I'm going to choose drop-down box West US because that's close by where I am. It's using a D1 to make it a simple, fast install. I'm going to be using Ubuntu server to go off and deploy. Go ahead and hit OK, and it's done. It's going to deploy it inside of my subscription called Rick Demo. And I'm going to choose, once again, to keep everything inside. Oh, I can't do that. I want to say create a new one. West US Demo. Resource group. And choose West US. These could have been parameters, of course. There we go. You do have to go through and click on the, read the licensing terms for this particular instance. Yes, I read them. Thank you. And then go ahead and create. That's going to go ahead and basically deploy 20 VMs, probably in less than about 3 minutes, all in parallel form to be across one subnet, all running Ubuntu server, D1 instance across my subscription inside of West US Data Center. Then that could be further configured additionally if I modify the template to run specific extensions to go off and further configure those boxes. Maybe I could configure it to talk to a chef server and receive further instructions on that chef server. While I'm here, I thought I'd go ahead and also show you a couple of quick things that we've made improvements on. One of the things, this is a machine I deployed a couple days ago. This is go ahead here and make it a little bit larger. A machine that happens to be a DS1. It's sitting inside of the West US data center because I wanted to go off and show you some stuff on the West US environment. But the neat thing here is that I have the ability to go through and choose troubleshoot. And inside of troubleshoot, based on talking with our support contract folks that do tech support for Azure, here are the most common things people have problems with VMs inside of Azure. I can't connect up to my Linux box. I don't understand how. I can't connect to my Windows VM. It won't start. My VM is slow. All sorts of stuff. So if I say, well, you know what? My VM is slow. Well, go ahead and take a look at how to monitor, diagnose, and troubleshoot Azure. Takes you right to the help links. Configure VMs for storage performance in the best way. Or I can even go through and open up a new support ticket directly all from here. Context sensitive, very cool stuff to be able to go off and to figure out what's going on. Even better than that, I can go through and check some health with that particular VM and let me know if that particular VM is currently healthy or not. And you can see here, on the diagnostics checks we've done, there's no problems with this particular VM. It seems to be working just fine. If you are having any problems, please go ahead and try to enable RDP, connect up to it, and take a look at it, and that sort of stuff. If I wanted to, I can also go through and configure alerts for other things that are on that individual box. Did I miss anything here? No, that's good. He's good, and that's good. One of the things that Microsoft Azure, the engineers have been working on so far has been trying to make it so that you have more insight into what's wrong with your VMs, how you can fix them, how you can work with them, make them more available. Again, trying to build on that trust to be able to make it so that it's happier. Another example of this would be, say, for instance, this other guy I've got down here. I can go through and, as you can see, I have an alert set up that goes in that I can create my own different types of alerts. There we go. I've got one that's called a CPU overload rule, where I've made a rule that goes ahead and tells me, hey, once it catches up, I create the description. I'm choosing a metric. In this case, I'm doing some very basic performance collection of CPU utilization that is over 80 over the last 5 minutes. Go ahead and email the administrators that there's something wrong with this particular VM. This will apply to this particular VM, can apply to other ones as well, if I wanted to. So this is going to set me up an email that comes off and fires off. If I go ahead and go in and connect up to this box, if I remember my password, good. I have a CPU stressor on here. I'm currently sitting at about 45 CPU utilization. If I go ahead and fire up a couple of more, that's going to crank me over the 80%. Within 5 minutes, I'm actually going to get an email that comes into my email information and says, hey, you've got a problem with this box, go off and fix it. Potentially, I could either go off and do some actual remediation on my behalf, as well as sending off an email to me that something goes wrong. If you want to see what that email looks like, I happen to save a copy of it. This came in at 10:56 today. There was an alert activated for CPU utilization greater than 80%. It tells you who it was. Click on the management portal, go off and fix it, and then tells you individual rules that were in error that activated this particular warning that I could then go off and troubleshoot and fix. This could be applied across different VMs inside of your environment to be notified of things going wrong across the board. Within the next 3-4 minutes, my box is actually going to go ahead and email me there's been a problem, and we can go off and have that guy fixed. One that I like as well, is kind of interesting, it's come up a couple times, more so on the Linux side of things, has been the ability to go through and I can't just go down the hallway to take a look and sign on the console to see what's going wrong with my box. I'm actually able to go ahead and take a look and say, what does the screenshot look like of that particular box? That was the screenshot as of just a moment ago inside of that box, inside the data center in West US, where this guy's in Australia, where this guy happens to live. And potentially, this is more important, not so much so from a Windows perspective, although it comes in handy. I'll actually be able to see the exact same thing on that Linux box I created earlier, right here, to go off and take a look at the boot diagnostics on this guy. And it's actually going to show me the serial output of what's gone on, that entire console of that Linux box going up and booting on an individual environment. So the Linux environment's going to go through and throw a bunch of stuff on the serial output inside the console as well for what's going on in that individual box. In this case, nothing too much has gone on over there, but hey, I've got the entire log of what it was, how it booted, and how everything's all working. I also have troubleshooting capabilities as well as the ability to go through and to do monitoring and alert diagnostics on Linux environments as well as Windows environments. Good improvements, all that kind of stuff has been trickling in over the last couple of months to get even more functionality. We make announcements about them on the individual blogs for Azure Compute. We also talk about them with individual alerts that happen to come up here inside of your alert areas. You can see here that my alert says my deployment succeeded. That West US demo has gone ahead and created 20 machines for me inside of my environment with all the different NICs, put them all inside of an availability set, and that availability set is now spread across 3 different fault domains and 5 different update domains, so I know that any applications running on top of these 20 machines are going to be adequately load balanced across them and also available in case those machines have to go through and be updated. I'll talk more about fault domains, update domains, and availability sets in my session tomorrow when I'm talking about architecting for availability and for performance. So we talked about compute, we've talked about the different sizes and stamps of machines, we talked about the basics of performance, we talked about the different ways you're going to be configuring and working with these things inside of an Azure environment with ARM templates, with infrastructure as code as far as the concepts are concerned. I'm interfacing and working with this inside of a portal environment. I could be doing the exact same thing through a PowerShell environment if I wanted to, directly in those individual boxes. And as you saw, I'm also just simply connecting up and working with the systems with my regular old everyday remote desktop capabilities in those individual boxes. Good, good, good. Done, done, done. Switch here. There we go. Once again, another short pause. Questions? Anybody? Questions? I don't know where they come up with these things. Like, it's crazy. Absolutely crazy. So people ask then, okay, well, I understand what's going on. The biggest thing I need to be focusing on right now is understanding the concept of Azure Resource Manager templates or ARM templates. How to get started with them is known as the Quick Start environment and how you can work with that Quick Start environment. Being able to go off and modify and work with those individual ones. But how do I actually get started with the Azure environment itself inside of a hybrid environment? Well, I asked you at the very beginning if you could spend some time and understand how you could make a hybrid connection inside of your lab environment. Go through and review Stu Fox's session around networking if you need to have a hand with that. But it really is quite simple. You need to have a public IP address that you can have an individual box that has an internet-connected public IP. You can, if you don't have any money to go off and to buy your own routers and to work with the sort of stuff that works with Azure, you could go through and actually just use an RRAS box with Windows 2012 on that box to be configured to be your IPsec tunnel that's there for a hybrid cloud environment. One of the ones that's actually going on right now next door in B2, or 1B I think it is, my colleague Pierre Roman is talking about Azure Site Recovery and Azure Backup, which is another great way to get started in using Azure environments as well. Azure Site Recovery and Backup gives you some legwork to get a very good business continuity plan in place, which will allow you to go through and do absolute identical restores of your information with Azure Site Recovery from on-premises up into the Azure environments. And then once it's been synchronized and working, be it a VMware hypervisor or a Hyper-V hypervisor, it makes those new boxes inside of the Azure world. You then go over and basically say, cut over, done, and it's now running up inside of Azure. The ones that are on-premises are still there, but you now have those same services up inside the Azure environment. That's one way of being able to go through and connect up and work with those guys. Another way that you can go through and work with stuff is a dev test environment. That's one of the conversations I constantly have right now, talking with folks. Azure is an environment where you saw some of the very cool things you can use right now with the Enterprise Mobility Suite to be able to go through and to manage with Windows Intune, individual workstations and handheld devices, that sort of stuff, being able to go off and control those different systems. That's all back-end and working with different Azure services. One of those is Azure Active Directory. Azure Active Directory can synchronize with your own on-premises directory, allows you to go through and use your on-prem infrastructure of identity, and then authenticate against third-party services, as Mr. Anderson went through and demonstrated. Likewise as well, from a dev test perspective, this is where you can go through and your dev test environments can be created inside of this ARM template and then deployed on that local box, made available after Azure Stack comes out inside your own data centers, or make them available inside the Azure environment. That can be checked into your source control capabilities to make sure that you're always testing and deploying against the same environments as opposed to bringing in human interaction that ends up messing things up. You also have the ability to do lift and shift with individual packaged apps. The idea is that usually you get involved, most of the time, at the same time, usually after the fact when a particular development project is underway, based on the maturity of how your infrastructure works inside of your office environments. When it starts looking at new dev test environments to be able to go off and deploy, they may or may not be considering using Azure or using AWS as your location. But you can go through and take a look at your existing information of services you run inside your environment from an apps perspective and decide, hey, these 3 boxes that are running, or this 1 box that's running for this one particular application, currently on legacy hardware or legacy virtualization environments, I could move that up inside the Azure world and make it available to my customers in some way, shape, or form because they only need to have it during certain times of the month, let's say. You could go through and actually do the work and the legwork to go through and move those different applications up to that environment. And then lastly, from a dev perspective, if you go ahead with your dev teams and you're working on something from the very beginning scratch, design it to work inside of a cloud environment from the beginning, Azure's obviously the place to go to be able to go off and to do that. This ends up being about 50% of the different workloads that are working inside the Azure world right now. What I don't see a lot of right now are things that are inherently, gotta have it from an infrastructure perspective, sit up inside the Azure world. I don't foresee you moving your entire native multi-site Active Directory domain controllers up into the Azure world. Don't see it. I'd see a synchronization going on. I don't see you moving your entire file system infrastructure from on-premises up into file servers up inside the Azure world. It just doesn't make sense. I'm not going to recommend it. In fact, if people are recommending to go off and to do these kind of lock, stock, and barrel moves of your resources from your on-premises environment up into the Azure world, you should nod kindly, say yes, okay, sounds interesting, and then just kind of make some doodles on a piece of paper like you're taking notes, and then leave the meeting quickly. I don't recommend you stick around for it because they obviously do not understand what's involved. When I get involved with design projects with different customers and organizations, usually it's because they had one of those conversations, they did not run to the hills like I suggested, and they end up looking like, okay, here is my big, massive existing line of business app that's core to my business, that is absolutely massive and multi-tiered and multifaceted. I need to now get this up into Azure. And you actually break those down into individual components. What makes sense to move to a cloud environment? What does not make sense to move to a cloud environment? Those are the kind of discussions that you have, and you find that it's really a reiteration or reworking of existing processes that would allow you to move stuff inside the Azure world or the AWS world or the Google Cloud world or any kind of cloud world, and by that fact. By analyzing how you can update existing stuff, that's when you go through and having to understand where things can move and where things don't move. All these different guys, done, deployed, did that. You guys have been very quiet, very helpful. I have 2 lovely maple syrup possible question incentives that are there. And so I have a option to say questions once again before I go off and show you something else at the very end. Any questions about Azure that you want to know about? In the red shirt, if it's a good question, you are the next person that gets to have one of those maple syrups. Question from the red-shirted gentleman was, I understand the concept of cattle, treating your servers as cattle and not as pets. And currently we do not offer console access to the individual boxes, or to the fabric underneath those boxes, I believe what you're asking about. Is there any plans to do so in the future? The answer to that is, we're doing our best for what makes the most sense. If you start to go down into those lower layers, you're no longer going to be able to look after, from an infrastructure perspective, the stuff that's going to be impacting your systems. because now you're going to be tweaking with stuff that we look after that's going to be affecting other people on those individual blades. We don't currently offer dedicated hardware to say you can go off and do that. Some cloud providers do offer dedicated hardware as an option where you would be able to have console access to that. The flip side of that, though, is, as you saw from some of those individual tools that run the troubleshooting side of things, we now are giving you the equivalent to look at the console as if you were physically at the box in case there were error messages, mostly on the Linux side. That was a big ask from the Linux community. We need to have serial output. We need to see what's going on those consoles if we're going to go off and trust that we can do stuff on the Azure environment. And so that was one addition that just came in the last month or so as one option. And more things like that are going to be coming out in the not too distant future as we continue to iterate on the product. So we're trying to find ways to give you the equivalent experience of what you want to do, but without having to give you access to all that stuff, because then that makes it so that we no longer are going to be controlling and working with our fabric. Is that a good answer? It's a answer. I don't know if it's a good one for you. So console specifically to that individual server. You talking from a Linux background or from a Windows background? Okay. Okay, so actually very good. So from a Windows perspective, he's had an issue where he's gone through and tweaked the individual boxes, screwed something up in the networking stack, or gone and done something where he's lost the ability to connect up to it through RDP. Have you tried the new troubleshooting options to be able to go off and to do stuff that I just showed you right there? So that new environment for troubleshooting just came out in the last couple of weeks for what's possible. I urge you to check that individual ones out. Those are currently available on side of classic machines. They will eventually be made across the resource manager machines as well. But they do have automatic repair options that we can do to those VMs to be able to fix them. Before you do, as I mentioned, the option of putting the server out of its misery, blowing it away, and simply going off and redeploying it. That's probably one of the biggest issues I've had in my 2 years of transition from on-premises to a cloud environment, is the inherent nature of the IT pro is we want to troubleshoot everything. We want to fix everything. We want to know why it broke so it doesn't happen again. It takes a lot of time, a lot of passion around it too. But sometimes there's a tipping point where it doesn't make any sense to continue to do that, and we just need to blow it away, restore the data, and then move on, because you've got about 1,700 other fires that we have to work on. That's been a very big learning curve for me to be able to do it. Doesn't always work on existing legacy systems, but if you design your new systems in that fashion, it definitely works as well. I think, what do you think? Does that deserve a maple syrup for the gentleman in the red shirt? So come on down later. You're the next one over here for the red shirted question. Congrats. Over there. I got to go to this side next. In the white.
So you mentioned about the storage would be you'd be protecting it, say, like 3 different areas.
Mm-hmm.
Is there an easy way to track whereabouts that is geophysically located to make sure that you don't fall foul of local legislative law?
Okay.
Keeping VMs in certain boundaries?
Yep, great question. That one there basically is talking about storage. Inside of a data center environment, you provision storage to run your VMs on, and that particular storage is inside that individual data center region. We talk about regions as opposed to data centers because in some larger regions, there are actually multiple data center locations inside that one region. We replicate the data within the data center, locally redundant, automatically. We can do region redundancy if you wanted to in some regions where they're larger. Automatically. So that would keep it all inside of East Australia. Unless you have something personal against Melbourne, it wouldn't leave Sydney. It would stay inside of Sydney. Hopefully you're not from Melbourne. I apologize if you are. The same thing applies mostly from a European perspective. As an example, if you're in Ireland versus England, the new data center happens to be in England, that sort of stuff, where it happens to sit. We're not going to move the data outside of the region that you go off and deploy. You're in control of your data at all times, where it sits and where it resides. Unless you say replicate this to a partner region someplace else, which is over 400 kilometers away, in which case, East US, West US, as an example. So that doesn't go anywhere. That's all yours and all your control. Good question. I just got your BitLocker must be configured. Let me close that window off in case I do another demo. I think that's also worth another one for you over there. Don't forget that. Anything else coming down? They asked me to leave 15 minutes at the end for questions. Again, I'm here all week, so. How about up? Oh, you're too close to the guy in the red shirt. I'll come down here. Yes, sir.
Related to the one in the red shirt anyway, about the Hyper-V console. host via the Hyper-V layer rather than, say, via a network. Is that available in Azure or plans to implement that?
So the question was basically the new way of going through the individual virtualization stack to be able to go off and have access to it through PowerShell, through that individual stack. That's something that's not a part of the hypervisor that we run inside of the Azure environment. So no, that's not possible.
So it possibly will be in the future?
That's not available inside of the hypervisor that we have running right now inside of Azure. And that's all. Let's just say that potentially anything's possible because things constantly change. At this point in time, with the way that we work in the Azure environment, absolutely not. We run and maintain all the fabric and all the different stuff of how that works, and that's what we do as far as giving you the best experience on top of that. Some of the technology that you find that are working inside the newer stuff inside of 2016, as an example, may eventually find their way inside of the Azure environment, may not find their way because it doesn't apply. And so basically, the engineering teams on both sides go off and share and develop stuff. So as an example of that, like RDMA networking technology for being able to go very, very fast between those different nodes, that kind of stuff is all possible because we are using Server 2012 up inside of the Azure environments to be able to have access to those RDMA drivers. That allows our VMs to talk very, very quickly to each other inside of the Azure VNet if you buy that type of machine to be able to have access to it. So it's fun going out to lunch with some of the engineers on the server side and some of the engineers on the Azure side at the same time because it's almost like a little bit of a back and forth for saying, oh, I've got this, oh, I've got this now, oh, well, I've got this now too. And they kind of go back and forth on it. So at this point in time, absolutely not. You have access to the console in a variety of ways, through either a screenshot, through a serial output log, or being able to look at the actual logs in the machine itself. But as far as the lower level stuff, we maintain all that, and that's all transparent to you, and you don't have to worry about it. That's part of a public cloud provider. I don't have any maple syrup left, but I do have stickers. So I have about a dozen or so stickers down here that says, my other computer is an Azure data center. You're welcome to come down and pick one of those up, and anyone else's option to be able to have one of those too there as well. Still time for at least one more question, possibly. Blue shirt over here.
Do you have any really good documentation about how to do the hybrid connections between Azure and the local environment?
Any really good documentation on the Azure environments and your local environment from a hybrid connectivity perspective? I'm going to say yes, because it has been out for a while. It hasn't changed per se. There's been some more detailed discussion and white papers around how to implement stuff on the express route, which is a bit more complex. We did make some changes to the Azure Gateway service, where we now have 3 different levels of gateways that you can choose to create for different levels of performance and cost as you run them, as an example. And it's all backed up on the Azure documentation side. One thing that's actually very cool with the Azure documentation side is that the entire documentation team for Azure has gone through and basically open sourced the documentation process, where literally the technical writer that's responsible for documenting Azure Express Route, as an example, has gone through and created the documentation on the azure.com site, which is actually being pulled from a GitHub repository that he or she is the owner of, to be able to accept pulls from other people and commits into that same documentation. As things change, the local product manager that's responsible for that technology, the technical writer responsible for that technology, and even community members that know that technology really well can make pull requests on that documentation, make changes, and then push them back up again. So it's always up to date. So that's one way they're trying to scale at size for the accuracy of our documentation that we happen to have. That's across the board for all Azure documentation. So things are going on. Personally, the VPN connectivity, you can do that, and I actually have a walkthrough guide if you want to, and there's actually one up on the Azure documentation site that will go through and walk you through every single step of how to go off and create it, provided you have a public IP address. So it is relatively simple to do. Very, very simple to do. I'm going to once again put up my contact details because we're getting close to the end. Some people are leaving. Thank you very much for coming, gentlemen, by the way. Don't forget your evals, please. Don't forget your evals. If you want to get a hold of me after this and you can't grab me in the hallways or at the, what is it, Movie World? Is that what that is on Thursday? To ask me questions there. Just don't do it while we're on a roller coaster or something, because it's hard to talk. Very hard to talk. Just go ahead and, again, look for me with the green hat to be able to find me, to be able to do stuff, and ask me questions about Azure. Or you can also obviously ask me through Twitter as well with Rickster CDN if you have any additional questions. I got time for one more. Anyone up? Back top corner. Yeah, you.
So on ExpressRoute specifically with the point-to-point circuits,
Mm-hmm.
the concept that there are multiple DCs in a region, do you have to have multiple circuits to each one of those DCs, or is it to an aggregation point so that you can use servers from each DC in a region?
Multiple contact points from your connection, MPLS connections into the data center that you want to go off and have access to. If there are multiple data centers, you have to worry about having multiple connection points that are into it. You connect into your VNet, which is established inside of a region. You're basically making a contractual obligation to your provider, which says, hey, provider, level 3, whoever you are, I need to have an MPLS circuit open to my network that happens to be up in Azure. Here's my details I need to have. They basically will go in and configure that circuit to be able to get it into the region, which is the data center that has your particular VNet, and you have a connection into it. The latest version of our VNets actually have the ability to have a site-to-site connection to them as well for backup purposes. So you're actually able to say if that express route connection goes down, you can go through my site-to-site connection with my traditional VPN gateway on an individual box if you wanted to, or you can offer an alternate route that's in there. We're very, very flexible for how you want to have connectivity into it, but generally you need to have one express route connection in. It's set up to be redundant with your provider into our data center, and basically you're getting access to your provider, that the provider has the connection that goes directly into our onboarding process on our data centers with their private connection between them, and it becomes transparent to you, so you don't have to worry about that. Does that answer your question? Good. Fantastic. With that, ladies and gentlemen, that's about 3 minutes left. Thank you for coming by and talking about this. I appreciate it if you would take some time and do an evaluation about the session. This was my introductory one for what's there. Thank you. I go into way more gory details tomorrow with regards to IOPS, performance, VMs, ganging machines together, that sort of stuff, for a much deeper experience. This is my foreign level session. This one's more of my introductory one. Thank you for coming by.
My many artifacts, the list goes on. If you just say the words, I'll up and run.